the grand finale presentation of the Hamoye Data Science Internship 2021 cohort. It's a privilege to also have Wale Akinfadere, who is a judge, who has been a mentor, and who has played a very significant role in ensuring that you and me and the millions of people around the world who want to be experts in this field get the opportunity and the platform to do so. So thank you again for joining us, Wale. And it's a privilege to have you always.
Yeah, thanks for having me again. I'm really excited to listen to the project, listen to what you guys have been doing for the past few months, and yeah, it's going to be exciting.
It's going to be exciting. Thank you so much, so much, Wale. So we still expect Charles and Biodun to join us. They were here last week and they judged the project, and it was quite exciting as well. We had to listen to presentations from our interns around different interesting areas like fake news classification, like mental health in tech workspaces, like suicide rate and price prediction of cars, population estimates, determination of cuisines. And it was an exciting journey last week. And now we are here to continue to listen to more exciting projects being presented by our interns. So while we wait for Charles and Biodun, I would just want to point out maybe one of our interns to explain to us his or her expectation for this presentation in just 2 minutes. And let's pick the guy that made it first to this meeting. That is Oluwasegun Olaniyan. Oluwasegun Olaniyan is also a presenter for the Scikit-Learn group, and I'm sure he has come with a lot of packages. So Oluwasegun Olaniyan.
Yes, good day, everyone.
Yeah, good day. Welcome.
Yes, I expect all presenters, we are going to be presenting a better project today, and we're just expecting our judges what our judges are going to say on what we're going to do. That's kind of expecting today. And I can't wait to see other projects also from interesting projects. That's a very good.
Okay, so I'm also tempted to ask, you've also participated in the last project, the Premier presentation. What is the difference in your preparation style from the Premier and this one?
Well, this one difference is deployment. I learned how to deploy models. The last one we didn't deploy, but we deployed this time around. This capsule project was not easy. So, because thankfully we were able to get a better result for it. So.
Okay, thankfully they were able to get a better result. So, like I said, and like Wally corroborated, it's been exciting to always come to listen to us make our project presentation, and we have the blessings of Wale to go ahead, if I am correct, Wale.
Yes, definitely. Yeah, you guys can start.
All right. So last week we had 7 presentations, and today we'll continue with the presentation from the group Prophet. Now, the group Prophet were champions the last time. Let's see if they would also come up again as champions. And this time they're talking about telecom customer churn prediction. And to present for them will be Kunle Adewale and Amit Peswani. I hope, Amit, I hope you're ready. I hope, Kunle, you are ready. So I'll go over before you come on, Amit and Kunle. I'll go over the rules again. Remember that you have only 5 minutes, nothing more than 5 minutes to make your presentation. And at the end of your presentation, Wale will have the floor to ask you any question that he so chooses. And at the end of every presentation, Wale would be willing to give you his recommendations. And at the same time, if any member of the audience of the Hamoye Fellowship, any Hamoye Fellow rather, have any questions for you, we can also take them there. So for the next 5 minutes, we'll have Amit and Kunle representing the Prophet group.
Good afternoon, everybody. My name is Adiwola Adekunle, and I am a representative of the Prophet Group. And today we'll be taking our telecom customer churn prediction model. Here is the list of my capable group members and the role they played in our project lifecycle. Firstly, I'm sure you guys are wondering what is churn. Well, churn is the rate at which a customer stops doing business with an entity. And as a telecom operator, it's important for you to keep your customers happy so as to prevent them from leaving to go into other services. As we all know, the telecom industry is really competitive. And that's why we, the Prophet Group, have come up with a model that helps you predict if a customer is likely to leave or not, so that you can entice them with offers or discounts to maintain their dedication to your service. Here is my process flow from data collection to final model deployment. Our data was got from Kego, in which contains 7,043 customers, 20 features, and one target variable, which is our churn. During our ED analysis, we noticed that there's a good imbalance in our churn, where we have a greater percentage of no churn to churn, as can be shown from the diagram above. This will cause a bias in our model, which will make it predict more no churn than churn. And we also noticed that we had some missing values in our total charges column, for which we realized there's a relationship that states that total charge is equal to the product of monthly charge with tenure. And that's what we used to fill our missing values instead of using mean or mode. This is our churn with respect to our numerical features. The first diagram is our tenure with respect to churn. The red color shows our churn and the blue color shows no churn. As can be seen from the first diagram above, there's a sharp increase in churn in the first 3 months and subsequent decrease as the months keep on increasing, which shows that the earliest customers are most likely to leave. Our second diagram is our monthly charge with respect to churn. It shows that as our monthly charge increases, so does our churn increase, which shows that monthly charge is a very good factor in people leaving your service. And for that, I will leave you now, my colleague Amit, to take you further.
Thank you, Kunle. Hello, everyone. Myself, Amit Perswani. Let me take you through the rest of the presentation. Now, let's see the distribution of churn with respect to various categorical features. Now, the churn was equally distributed for both the genders. So, gender was not an important feature while deciding the churn ratio, whereas the age was an important factor. We observed that the senior citizens were more likely to churn. Further, we also noticed that the customers without any dependents and without any partners were more likely to churn. Also, as we all know that fiber optic internet service is more costlier than the DSL lines, so we observed that the customers with fiber optic internet services were highly likely to churn as compared to DSL. And one important point to note is the customers who did not opt for the additional services such as online security, online backup, device protection, and tech support were more likely to churn. So the customers who are not taking these services, it can be taken as an early indicator of potential churn candidates. Now, on the left-hand visual, we can see that this telecom operator provides 3 different types of contracts. That is month-to-month contract, 1-year contract, and 2-year contract. It is clearly evident that the customers in month-to-month contract are most likely to churn. Now, if you will please shift your focus on the right-hand visual, we are able to see, although the churn is present in all 3 different types of contracts, but in each type, the customers that churned were paying higher monthly charges compared to the customers of the same category who did not churn. It means to say that monthly charges will play a very important role when predicting the potential churn customers. Now, as for the feature engineering, since there was a high class imbalance towards the no churn, we did the undersampling to achieve the class balance. And we had a mix of numerical and categorical features with a total of 20 features. The numerical features were found to be nicely correlated with the target, so they were kept. And there were several categorical features for which either the churn was equally distributed or they had very low correlation with the target variable, hence we dropped them. Further, for the remaining categorical data, we used the one-hot encoding method. And for the numerical data, we used min-max scaling for the normalization before sending them to the machine learning model. Now, as for the machine learning and experimentation, we tried several algorithms and we did various type of experimentation and found out that AdaBoost was performing consistently well in all of the experimentation. To further improve the performance, we also used hyperparameter tuning and found the best parameter values. Now, using those best parameter values, we narrowed down to 8 best features. Now, with those 8 best features, we have deployed our model. Kindly allow me to take you through the live demo. Now, let us choose some options. For example, if the customer takes internet to be fiber optic, let's say they have a contract of month to month, and let's say they are a short on tenure, like 2 months only, and maybe some high charges as 100. Okay, now you see, this is a churn type of customer. Let us go through another type of example. Let's say if they have the internet type of DSL, their contract is like 2 year. Let's say they have already completed 22 months out of 24, and let's lower the charges to 60. Now, this is a no churn customer. Now, you see, these predictions go hand in hand with our insights that we just draw from our presentation.
Amit,
let me take you.
Your time
Yes.
is up, so round up in less 10 seconds, please.
Okay, yeah. So, yeah, the challenges faced were the class imbalance, choice of good algorithm, and the reduction of 20 features. And lastly, as per the conclusion, we have developed a basic model with 8 criteria, but we would like to do it with other features as well and on a larger data set. Thank you. If you have any questions, you are most welcome.
Thank you so much, Amit and Kunle. So, Wale, do you have any questions for them?
Yeah, I have a few. Thanks for the presentation. The first question that I have is that what actually informed your choice of undersampling? So I'm guessing you're doing random undersampling. Do you actually think about the fact that you're undersampling? It's very possible that you might lose critical information from customers who do not join.
Yes, you are right. So that's why we tried the same method again and again and did the experimentation so that we can make sure that we are not losing on important information and that we achieve consistency. Yes.
Yeah. Then I think the question is that the imbalance in the classes they're not extremely large. It's like 73 to 27%, if I'm right. Did you run the model without doing any of the sampling methods? That's one. And two, did you try to use some form of oversampling method? So trying to oversample on the minority class?
No. So why we did not do the oversampling? Because we knew that since the because of the difference among them, we thought rather than oversampling, it would be good to undersample because we will be retained with the original data. That's why we went with the decision of doing the undersampling and not the oversampling.
Okay, that's good. And then my last question is that apart from the fact that you have the metrics that you were looking for, so I could see the AUC, the F1 score, and the other last one, and the accuracy, and then you picked AdaBoost, right? Do you even consider so you were looking at it from the metrics point of view, but sometimes a model can be good if the metrics, if they are low, but the model is very interpretable, very explainable. So the reason why I'm saying that is that I really like the UI that you guys did with the deployment. But if I am an executive, or if I'm a business manager, for example, and you come with a prediction model, right, that, oh, this customer is likely going to churn or not, I am actually more interested in the recommendation, which is why exactly is the model predicting that a customer will churn? So did you guys give any weight towards like trying to provide explanation for your model, or is it something that you guys have thought of?
So see, the things that we went here, right here, like, for example, we saw, I think you are talking about insights, if I'm not wrong, senior citizens.
Yeah, so this is this EDA that you guys did, they're really good. But also think about the from a global perspective, right? So this is a global, like this tells you in like it's a global sort of averages across the entire data set. So I mean, I'm saying like if you have like a single data set, like a single training example, or testing example for a customer, did you think about, so the reason why I'm saying to is that other boost has a certain
That we-
level of complexity.
Yeah, understood your point. The insights that we drew while the EDA and the results that we got from the machine learning while putting those typical characteristics in the model, they went hand in hand. That gave us much confidence that the EDA goes hand in hand with what the machine learning model is showing as the output. That's why when you saw that why I chose the certain type of internet connection, why I chose the certain type of contract type and the tenure as well as the monthly charges, because that was observed in EDA as well as the machine learning model threw up such results. So that's what gave us much confidence that machine learning is going hand in hand with what we did with manual EDA.
Okay. Yeah, that's very good. So I would say, good job. Yeah, pretty excited.
Thank you. Thank you.
You're welcome.
Thank you so much, Kunle. Thank you, Amit. Great presentation, like Wale said. So we proceed to the next presentation, and that will be from PyTorch Group. They're talking about the chances of a person having a heart disease, and to represent that group will be Omotosho Abdul Martin. Omotosho, this is your time.
Sorry, can you guys see my screen?
Yes, we can see your screen.
Okay. Yeah, good afternoon, everyone. My name is Omotosho Abdul Martin. So I'll be presenting for the PyTorch group on the project topic, heart disease classification. So these are the names of the members that contribute to the project. So introduction, as you all know, we are to build a machine learning model that will help in making it easier to predict if a patient is with heart disease or not, so as to start treatment immediately for the patient. Heart disease has proved to be one of the leading causes of death for both male and female, and it is difficult to identify this disease due to several factors contributing to it, such as the high blood pressure, the chest pain, and so many other factors. And since ML has proved to be effective in making decisions and predictions, so we are going to be leveraging on it to solve this particular problem. So the data set was gotten from the Cleveland database from UCI Machine Learning Repository. It consists of 14 columns, and the target columns shows if the patient is having heart disease or not. So here we imported the necessary library needed for data visualization, data analysis, and the machine learning model building. So we have this bar chart showing the distribution of the target column, where we have 1 representing people with the disease and 0 with people without the disease. And we have approximately 165 people without the disease and 138 with disease. The bar chart below is showing the distribution according to gender. And here we can see that like 24 female and 114 male are without the disease, and 72 female and 93 male are with the disease. So this heat map is showing the correlation across different variables. So we make use of this heat map so as to find if 2 variables are correlated. So as to drop one so that it will not affect the model. And here we have another scatter plot. From this scatter plot, we can notice that people with high mass heart rates are with the disease, and their age ranges from 40 to 60. And then the bar plot below is showing that people with chest pain type 2, 1, and sometimes 0 are more likely to have heart disease. So basic cleaning of the data was done, like removing of the null value, converting of the categorical variable to numerical, and some visualization was also drawn out, which has been shown above. The data into 80% sets. We scaled the data the features of the data using standard scalar. Then we train the data set on different classification algorithms, such as the wire. Then we find out that the logic parameter tuning come out with the best accuracy of 88%. So this is the code showing the training of the model, and these bar charts at the right-hand side represent the accuracy of different algorithms, where we have the logistic regression with 88%, the KNN with like 65% accuracy, and the random forest with 81% accuracy. Then we plot the confusion matrix. The confusion matrix is showing that 25, that the model predicted the value to be 0 25 times, and actually the value is 0. And 29 times, the model predicted the value to be 1, and the actual value is also 1. Then the model also predicts the value to be 1 3 times, but the actual value is 0. And then the model also predicts the value to be 4, the value to be 0, whereas the actual value is 1. We also plot the ROC curve, and the ROC curve to show the performance of our model. And then we have area under a curve of 0.9%, which shows that our model is pretty good. So summary and conclusion, the accuracy of the prediction for this heart disease project is reliable with 88% accuracy. And then we should notice that out of like 4 females, 3 are likely to have heart disease, and 1 is likely not to have. And for the female, out of 2 people, 1 is likely to have and 1 is likely not to have the heart disease problem. And special consideration should also be like people with chest pain 2, 1, or 0 should be looked into, because they are the people that are likely to have the heart disease problem. Thank you very much.
Yeah, thank you. Thank you again. Wale.
Yeah, thanks, group PyTorch. I don't even know if you guys used PyTorch or not. Yeah, I actually do have a lot of questions. The first one is that I was just wondering, and anybody from your group can answer the question, I think. I'm not sure, but I was just wondering how you did a correlation matrix combining both categorical and numerical variables. That seems to be a little bit weird to me, because how do you find the correlation coefficients between the gender and maybe a REST ECG rate or something?
No, the correlation coefficient was actually the heat map.
The correlation matrix, yeah.
Yeah, was done only with the numerical features.
No, I could see features that are not numerical there.
Like,
I could see, I mean, sex is not numerical.
Yeah, in the data set, sex was represented with 0 and 1, like 0 for female and 1 for male.
Yeah, even though the numbers are numeric, right? They're actually categorical. And then there's some other features here also that are the same thing, that actually I can't remember, because I've worked with this data set before, that are categorical. So what I'd say is that, yeah, I don't necessarily think you get very good signal from trying to get a correlation matrix with something that is actually, because sex is male or female, whether they represent it to a number or not. So it's the numbers could be numeric, but it's not a continuous value. So that's what I was looking at. And then the second question that I have, and that's a little bit of a concern, is the null values, right? So you say you guys remove null values. My major concern is that every null value you remove is actually a patient record. It's a real patient, right? So if you remove, are you removing the null value row wise, or how are you doing it? Because it's actually someone's life. So I was wondering how you guys made the decision.
Yeah, actually, the null value in the data set was, I think, was like 2 or 3. So we just decided to drop it without maybe removing into its main mode.
Is it 2 or 3, like all the rows, everything were actually null values, or you have some?
No, not everything, just some of them, not everything.
Yeah, so the problem is that you can get sued for that, because it is real human lives, real customer data, and it could be anyone. So sometimes, I mean, it is tricky also if you cannot do anything with the data set. But I've seen people also do like imputation or something like that. So that would work. The last question that I have is a tricky question, right? So you have it's not really tricky, don't worry. You have I'm guessing you know what the false positives are and the false negatives, right? So and the reason why I'm trying to ask is that the false positive means that you predict that someone who doesn't have heart disease, right? You predict that they're going to have heart disease, right? That's the false positive. And the false negative is like someone has like heart disease, and then you're telling them that no, they don't have, right?
Yes.
If you're a doctor, what are you going to optimize for?
If I'm a doctor, so I would definitely go for not having the disease, but that's a tricky question. Wow.
So this is not, it is not a yes or no. But I just wanted to give you guys a little bit of like more perspective on how you can actually, like, if you're in a situation, right? So there's a reason. So machine learning in healthcare is extremely tricky. A paper was recently published that 99% of all the research that were done in machine learning for COVID studies, even more than 99%, were never used by the doctors or in hospitals. There was just research that were done and published and waste, right? And so that's where nuances around, for example, as a doctor going to use my model, what are some of are they going to optimize for some of the metrics, right? So that's why I said that and anybody can chime in, actually, it doesn't have to be a group alone, right? If you're a doctor and someone builds a model, or you are also the one that builds the model, and you have the false positive, which means these people, they don't have cancer, not cancer, heart disease, but I predict that they have heart disease, or the false negative, which is people that they actually do have it, but I predict that they don't have it. If you're in that situation, what are you going to optimize for? What do you think carries more weight, is more important for you?
Okay. I think people that do not have it and the model predicted that they have it, I think I will actually go for that, because people that have it and the model is predicting they do not have it, that can maybe lead to maybe a death or worsen the case.
Okay. So which one do you think which one will you try to reduce out of it too?
Okay, people that do have it and the model is predicting that they do not have it.
Okay, sounds good. Yeah, that's exactly what I'm looking for. You kind of optimize for false negative. Like it is much better for you. No, you don't reduce it, right? actually, no. So it's much better for you to predict that people that, yeah, I think you're right. That people that they don't have it, that they have it, than people that have it and then you say no, and then they're much more likely to die. I mean, the people that if they don't have it and you say they have it, you can always do another test later on
Yes.
to check,
Yes.
right? So okay, yeah, brilliant. Thank you. Yeah.
Thank you very much.
Thank you, PyTorch Group. It's becoming more interesting as more people are joining the conversation, trying to answer your question, Wale. So maybe I'll just take a few seconds to read out some of the responses, so that for the sake of those on YouTube who may not be able to see them. So Kennedy is saying false negative is the worst. And like telling someone who's HIV positive that he's HIV negative, that can be deadly. Chukuma is saying check the model against p-value, optimize it to be lower. And then Frank is saying precision, recall, or just F1 score. And if you have more to contribute, please feel free to put it up.
Yeah, I think I actually like the area where Chukuma is going, where you check the model against p-value and you can sort of start by declaring some hypotheses, and then you can try to look at your prediction between some confidence bounds. So that's brilliant. Also, I think Frank's answer around precision, which is I think the total true positives over the you definitely kind of want more precision in this case. So that's good. Yeah. Thanks, guys.
Great one, guys. Great one. All right. So when you were trying to explain to the PyTorch presenter, you mentioned something on COVID, and coincidentally, the next presentation is on COVID, but this time not on the health side, but on the economic impact side, and that will be done by the Scikit-learn group, Olaniyo Oluwasegun. Shegun, so it's your time now.
Good day, everyone. I'm Olaniyo Oluwasegun. I'm representing my group Scikit-learn on the impact of COVID-19 pandemic on the global economy. Here are my team members that participated in this group in this project. So COVID is a respiratory illness caused by severe acute respiratory syndrome, which started in Wuhan in 2020 and started spreading across. We started in Wuhan, China in 2019 and started spreading across all countries in January 2020. And the World Health Organization also declared it as a pandemic in March 11, 2020. So how can this, amounting to over 3 million cases in over 218 countries and territories. So how can this impact affect the global economy? There are various ways, which includes reduction in income and productivity, rise in unemployment, business closure, and loss of life, which all this can cause depression, resulting in high rates of death cases. So our team made an emphasis on predicting death rates for different countries and globally also, in order to help to prevent this impact. So here are the methodology we used to achieve our goals. And we got our data set from Kaggle, and here are the features we used on the data set. And the libraries used for this project are also this. And during our exploratory data analysis, we made some different analysis based on the daily cases, the daily death cases, the daily active cases, recovery rates for different countries. We also did globally. So here are the few images from our exploratory data analysis. So in this stage, it was split into 3 phases, whereby the first phase we used Prophet model, and we split our model into training and test. We did model training, evaluate this model using root mean square. Then the second phase, we used the mean max scalar on the data set. We split our data and use various models and evaluate these models using root mean square. And the last phase was we used standard scalar, but this time around we used it on just 5 countries. Other ones we did was globally, while this was for just 5 countries, and we used different models also, and we evaluated them using different matrix evaluation. We evaluated them using root mean square error. So here are the results we got. For the first phase, where we used we used Prophet model, which we got root mean square of 2,458. Then the second phase for global prediction, we used this is the results we got, where extra tree had the best root mean square error. And for the last phase, where we did for each countries, SG Boost had the better prediction for Russia, Brazil, and USA. Then support vector machine had the better prediction for Australia, and gradient boost model had the better prediction for Nigeria. So for here is a prediction of the next 4 months using Prophet model. So here is the link to our deployed model. So I'm going to show everyone. We used Heroku, and our web page was built using Django. So we have 2 pages, which is the global and specific. So for instance, let's say we want to see the test rate. We choose the date we want and click on check. Click on check. So it will show, it will predict that it says there are over 13,000 cases in January 2020. So for the specific, after clicking on, we click on the button specific, and we choose the specific countries, the 5 countries we used to train our models, and select the date. We select the active cases.
Your time is
Okay,
up.
then you click on check.
Please round up.
Click on check, and it will predict yes, for the country, the test case for the country. Then our conclusion was to have domain knowledge experts to put us through on other things we can do, and find a way to get more features to the model. Thank you.
Okay. Thank you. Can you go back to the slide, 2 slides back? Not this, another slide back. Okay. No, that one. The plot. Okay. So this is global, right?
Yes.
Right. So you have the data is from February to April, right? And so you have the first wave around April to May. There's a little second wave in August, and then there is the last wave in December, right? So you could see 3 major peaks. What are the assumptions for your time series model? Were you just assuming stationarity, or because this is good job first, but this is a very difficult project because there's so many unknowns, right? So I wanted to understand, were you guys looking at some of the waves and trying to feature some I don't know, maybe some cyclic pattern or something?
Concerning the stationarity, we use the ADF test. Yeah, the ADF test, and we found out that it was stationary.
Okay. And then the other question that I have is that the RMSC is very tricky, and it could be very sensitive to outliers, right? Do you think there are like other metrics that you should have considered outside like the RMSC and the R score?
Okay, we only considered the RMSC for this subject.
Okay. Okay. Can you go back a little bit? I wanted to just see the EDA again, if you don't mind. No, go back. Go back. Okay, wait. Okay, then, so it means that the results that you had were actually global results, so you don't have models for each specific country.
No, this was not derived from the model. This visualization was what was on the data set.
Okay.
Yes.
Then go forward a little bit. Sorry, I just wanted to wait. Okay. How did you split your data set? Was it random splitting?
Yes.
Okay.
Yes.
So let's go back, let's think about this random splitting, if that's what you did, right? So you have a data from February 2020 to, let's say, April 2021, right? If you're random splitting, it means that you probably have data from like 2021 in your training set and you're using it to predict 2020 or something, right? Do you think there could be a better way for you to split it? And I think anyone from your group can answer. It doesn't have to be only you. If they're here.
What I could say is, for the when we use prophet model, I think we that one wasn't random. We took like 80%. Then we make prediction. But for other models, it was random.
Okay. Okay. Yeah. Okay. Yeah. I think that's all the question I have. I'll probably add a few comments. But the comment is that when you're dealing with time series, you cannot do random splitting.
Okay.
You cannot also do the normal k-fold cross validation, and there are a lot of reasons, right? So mostly what you do is what they call forward or backward split, forward splits, which means that you use the first 8 months, for example, to train, and then the next 4 months to test. And I think that's what Prophet would give you. And that's why the validity of like the other models, like XGBoost, and they're definitely, there are a lot of questions for them, because you cannot do a random split in time series. Basically, you bias your model heavily, and it doesn't really become extremely useful. So and I think that's the question I have. Great job, guys. And it looks like we're about to get into another wave now. So it's getting crazy. Yeah. Thanks. Yeah.
Yeah, thank you so much, Wale. And well done, Oluwasegun. So Chukuma also shares the same thought with you, Wale. He says a better way to split would be a selected number of months for training and later ones for testing. Maybe that's something to take note of by the scikit-learn team. All right, so we'll move on to the next presentation, where Oluwatoyin Ademarati and Akinleye Oluwafemi will be talking about the analysis on the sales of video games.
Good afternoon, everyone.
Good afternoon, Tony.
All right, my name is Oluwatoyin Ademarati. I'll be presenting on behalf of my group, the SkyPie group. Sorry, I'm trying to share screen. Please, can we all see my screen?
Yeah, sure, we can.
Okay. Like I said, I am Oluwatoyin Ademarati. Akinyele Oluwafemi will not be around today to present, so I'll be handling this alone. So I'll be presenting for my group, the SkyPie group. What we worked on is analyzing sales of video games, and we're going to do a little bit of predictions based on some criteria like the platforms, the publisher of the games, the name of the games, and others. These are the members that participated in the project. And so what we'll be doing or what we did actually was to gain insights from the data that was analyzed. We were able to get data of game sales from 2009 to 2013. So we put that together, and we are going to do some exploratory data analysis and do some predictions based on the data that we have. So some of the details, sorry. So these are the correlation. These are correlation match heat maps based on the correlation between the year, the sales from different regions, and the ranking of each game. So based on our analysis and visualization, we were able to discover that game sales was increasing over time, and in 2008 it reached its peak, and since then game sales has been dropping. That's the amount of games that were sold over time has been reducing. We do not have sufficient data to tell whether what has been causing the decline in the game sales. I believe that this is what we would have been able to work on if we had more time, and if we had more data to analyze and work on over time. Also, we discovered that game sales was highest in North America, then followed by in Europe. So we're able to show a visualization of game sales in different regions. And what we're able to find was that in North America, it was highest over time, and then followed by in Europe. Also, we also were able to compare game sales with gaming platforms. So we found that the gaming platform with the highest amount of sales was the PlayStation 2, then followed by the X360 games. We used regression model, the linear regression model, to predict the price of game based on the name of the game, the year the game was deployed, the platform with which the game was deployed, and the genre of the game, as well as the publisher. So these are some of the challenges that we faced. The data that was used do not have the amount or the price in sales. Hence, we're not able to speak on the overall turnover of the market. Then the data that we had too was not recent. Like I said, we had to use data from 2009 to 2016. So we weren't able to get recent data. And we also had the limitation of unavailable details, especially with respect to the people that bought the game, such as the age and the consoles that are available. That will be all that we have for you today. Thank you.
Yeah, thank you so much. Can you go a slide before the limitation slide?
Okay.
What
Yeah.
about before this?
Sorry? The one
The
before
slide before
this.
this, yeah.
Okay,
Okay,
okay.
so did you build any model or not? I wasn't sure.
We built a model.
Okay. You didn't have like the information about the model on the slide deck.
Yes, we don't.
Okay. Do you know what model did you build?
We used linear regression to do the prediction.
And you're using it to predict the sales, right?
Yes, yes.
Is it the sales per month or is there any like extra nuance
No,
to it?
there was no metrics. We had
Okay.
the sales for different years.
Okay. And so my question is that is there any pattern, for example, let's say I'm someone that want to go into the gaming industry or the gaming business tomorrow, right? And then I come to you as a data scientist to give me some recommendation. What would you recommend and what would that be based on?
From what we did was the available data we had was to use the genre of games, and for like if you look at this visualization where we compared the genre of games with the game sales, I can say that um we can say that most likely North Americans buy more games than other regions. And for those in North America that bought the most, they bought action games.
Okay.
So for someone who is going into gaming or who wants to produce games, we will be able to recommend that, okay, for you to make more sales, you can sell in the North American region, and what you will sell the most is action, then followed by sports games.
Okay.
Yeah.
Okay. Sounds good. So yeah, action, then North America. Okay. Yeah. Thank you so much.
Yes.
So thank you so much, Queen, for this one.
Yeah.
We'll move to the next presentation, and that will be on image caption generation. And that will be given to us by the Scrappy group, represented by God Bless James and Happy Okodua.
Yeah, good day, everyone. I'm God Bless James of Team Scrappy. And in today's presentation, I'm going to walk you through a project on image caption generation using deep learning. So basically, image caption generation has to do with building systems to understand the content of an image and automatically generate descriptions based on the understanding of the image. Yeah, so with that said, in the following slides, I'm going to talk about the problem statements. I'll discuss the data set and highlight some of the implementation details as well as some of the results we achieved. So there are surplus amount of image data on the line on the internet today. And as you can see on the screen, an average of 3.2 billion digital images are shared every day. Wow, that is a huge amount. And even though humans can easily describe an image by looking at the image, this task becomes difficult and tedious and time-consuming if the image is huge. So hence, it becomes reasonable for us to want to automate this process of generating captions. With that said, talking about the datasets, in this project, we've used the Google Conceptual Captions dataset produced by the Google AI team in 2020. Now, some key features of this dataset are that it is currently the biggest image captioning dataset with approximately 3.3 million images annotated with caption. And two, it has a wide variety of image types. Like you don't only see normal traditional images, but you can find cartoons alongside their caption and also other graphical illustrations. And then talking about the captions, this data set has captions that are contextual. As you can see on the screen, this caption, a modern painting meets visitors upon entry. What it does there is it doesn't just simply describe the objects recognized or identified in the image, but there's actually a context to it. So for the sake of this project, we downloaded 50,000 images, and then we used a 90 to 10% trained validation split. So next, I'll be talking about the implementation details. So the first thing we did was to download and pre-process 50,000 images from the links provided in the dataset. And after doing that, we pre-processed the captions as well, normal language, natural language pre-processing techniques, removing of punctuations and all that. So after that, we utilized the Inception V3 model pre-trained on ImageNet to actually extract the image embeddings from the images, and then we cached this into disk. And after doing that, the next stage was to do sequence modeling and generate the actual captions. For that, what we did was to implement a transformer encoder-decoder model as specified in the paper, Attention is All You Need, by Vaswani and his colleagues in 2017. So as you can see, the image just simply summarizes what the process of generating a caption. So the first thing is the image is fed into the Inception V3 image classification model, and then the features are generated, are extracted from the image, and this is fed into the encoder, which converts them to tensors. And then the output of the encoder is fed into the decoder. And as you can see, the decoder just simply converts the features to words and then links the relationship, and then a caption is generated. So in the next slide, these are some examples as we use the model on our testing data set. So you can see there, a young woman standing by the stove in the kitchen. You can see passengers were left terrified as the plane landed. That is, you can see the context in that. It's not just describing what is happening there. You can see the cartoon-like image here, a minibus on the forest road. So in summary, what we've been able to achieve in this project is, one, we downloaded and pre-processed 50,000 images, and this took between 4 to 5 hours to complete. And we pre-processed the image captions as well. And then we used the Inception V3 image classification model to extract 50,000 features. This process took between 1 to 2 hours to complete as well. And then we implemented the transformer encoder-decoder model architecture. And last but not the least, we trained the model on about 40,000 images. And this training process took in total about 24 hours because we utilized the Google Colab GPU, and it just has a 12 hours free access. So we had to use checkpoints to incrementally develop to train the model. So now the state-of-the-art models in image caption generations are trained on hundreds of thousands of data, but this is not the case in our project as we've used just 50,000. So we believe that we actually had constraints in terms of computing resources. So we believe if we can acquire more computing resources to train our model on the complete data set of 3.3 million images and captions, then our model will definitely be very good, and we can actually deploy it in real use.
Your time is up, James.
So with that, we can build an innovative web app, and everybody can have access to it. So thank you.
Yeah. So I'm still trying to understand a lot of the different aspects in the project. Thanks to your group, and thank you for the presentation. Now the first thing is that there's the Google conceptual caption data set, which is 3.3 million data set. And then you guys had 50,000 images.
Yeah.
Where is the 50,000 images coming from?
Yeah, so the thing is, the Google conceptual captions data sets, they don't really have the images. They only have links to the images and then the captions. That's how the data set is prepared. So we have to download the images ourselves to our local disk to be able to use it. So we just wrote a program to access the links and then to visit the links and then download the images into our local.
Okay, so the 50 images are from the 3.3 million annotated images.
Exactly, 50,000 images, yeah.
Okay, so I'm assuming you randomly sampled and you just took 3.3 million images, right?
Exactly, yeah.
Okay, that's the first question. Good. And then you did a train validation split. Because my question is that there's absolutely nowhere in your presentation where you discuss things around metrics, how well your model behaved, what are some of the good examples where it was able to like create captions properly for images, and the ones where it actually needs improvement. I'm not sure I actually saw something like that.
Yeah, you're right about that. So for the metrics, for the image caption generation tags, the metrics used there are the CIDER, that is the consensus-based image description evaluation, the SPICE, which is the semantic propositional image caption evaluation metric. So we actually did the evaluation, and for the first one, the CIDER, we achieved a score of 0.127. And for the SPICE, we achieved a score of 0.138. Now, this scores, as compared to the state-of-the-art models, they are really poor, considering the fact that we only trained our model on 50,000 images as compared to the 3.3 million available. Now, I showed some examples of how our model performed, but I think I didn't include some of the some of the descriptions that were not really good, but these are some of the good ones here. As you can see, young woman standing by the stove in the kitchen. Passengers were left terrified as the plane landed. So these are some of the results we achieved, the good results.
Okay. So I think that kind of answered my question, because I was also sort of initially very skeptical, especially with 50,000 images. Deep learning is very data hungry. It actually scales better when you have data, and I mean, you guys are using the transformer architecture in your model, so you need a lot of data. I mean, I think the only comment I would make is that sometimes it's always better to have like a sort of more complete approach where you present also some of your metrics for validation, and some examples where it is not doing very well, even without like stock images. That's one. Then the other one is that what would have probably helped you guys is to use transfer learning, right? So the idea about transfer learning is that there are models out there that they've been already trained on, like this 3.3 million. You can actually take them and then you can retrain maybe the last few layers based on, and also use your own training data set. And with that, you can transfer the parameters from the original, the trained model that was the model that was originally trained on like a huge data set. You can use those parameters and include them as part of your process for your small data set. So transfer learning tends to work very well for tasks like this. And when you do that, you also don't necessarily need to like train for so long, especially if you don't have access to high quality GPU. So sometimes using transfer learning implementation helps when you're sort of in these compute constraints and very small data set region. But yeah, overall, yeah, good job. Thanks.
Yeah, so the thing is, we actually use transfer learning for extracting the features. Like I said, the Inception V3 model is already pre-trained on the ImageNet dataset. I think is the winner. Yeah.
Okay. So you use the transfer learning to extract the features, and then you just put the transformer on it. Okay.
Yeah, and then the data set is actually no implementation has been done using it like open sourcely. So it's actually a competition on the Google website, like that people can actually, they request people to write models to test on the data set. So there's no model that has been trained openly for this data set. Okay. So other models like the MS Coco and Flickr, those are the ones available. So we wanted to get our hands dirty and really test something new. So that's why we went for the Google conceptual captions. Okay. And to train a model from scratch, yeah.
Okay, sounds good.
All right, thank you, James. Thank you, James. Great work, I must say. Um, so we move on to the next presentation, and that will be given to us by Raimi, who's representing the Seaborn Group, and his project is on suicide causes and prevention. All right, yeah, Raimi, you can proceed. 5 minutes.
All right, good afternoon, everyone. Just confirm if you can hear.
I think we can only hear you faintly.
Okay, all right, good afternoon. Can you hear me?
Good afternoon, but it's still faint. I don't know. Wally, can you proceed with how you hear him, or would you like it to proceed like that?
No, it is very faint.
Very faint, Raimi.
Okay, good afternoon, guys. Good afternoon, guys. Can you hear me now?
Like I said, we can hear you, but it's faint.
Okay, please give me a minute. Okay, good afternoon. Can you hear me now?
Good afternoon. I think this is better.
All right, great. Sorry about that. I had an issue with my mic. My name is Raimi Aziz. I'll be presenting a topic on suicide rate analysis and fate prediction. That's text prediction. All right, introduction. Suicide and mental health generally is a global issue, and there's about 800 people who die of suicide globally every year. That means there is, for every suicide, there's about 20 suicide attempts, which is actually a lot, and brings mental health as a very, very major issue in the global sphere. All right, the objective of this project is to analyze suicide across different countries, age group, generations, and years, and also build a model that assesses the mental health of individuals using their social media, Twitter in particular. Okay, before I go ahead, I would just like to say that if you're going through a downtime or having struggles with your mental health, please don't be afraid to speak up and seek for help. The data set used in this project, these are the data set used in this project. They are gotten from Chicago. The first two were used for the analysis, while the last one was used for the prediction. All right, the approach is to build a model, a machine learning model that predicts tweets from Twitter. And this was done using NLP, and these are the steps that we're taking. 3 different models were built. That's the logistic regression, multinomial, and naive bias, and the SGD. And then this was actually assembled using soft coding, and the accuracy was 89%. As for the test accuracy, there's a screenshot of the individual machine learning model, and these are my results. All right, for this is showing the male-female statistics from 2000 to 2016. You can see there's a high rate of male suicide between 2000 and 2016. And this is the male-female comparison by year. And this is by age group. You can, surprisingly, the 35 to 54 years age group have the highest suicide rate. I mean, those are the people who have actually gone to life struggling through it. All right, so as for the generations, the GI generation, that's, I believe these are the generations that spilled out from World War II. That's between 1985 to close to 2000, year 2000. The suicide rate is actually alarming. You can see the millennial generation down here. I mean, these are still coming up. And the Gen Z, who, I think this is actually positive comparing, I mean, considering that the awareness of mental health has actually increased, and I think the Gen Z are actually, doing better compared to the previous generations. This shows 96 point, that's about 97% of male the suicide rate of male compared to the female, and we have about 97% male more than the female. This shows the worldwide suicide rate in 2016. My prayers and thoughts with Russia, they have well over 120 suicide by 100,000 population. Skip this. Okay, Nigeria. I took a quick look at the statistics in Nigeria. Surprisingly, again, we have more female suicide compared to male. We can see that it's actually declining around 2015. This is the data I have. Around 2015, and the male suicide population has increased. I did a simple linear regression using the data, and it shows that there are the male population commits suicide 8 times more than the female, and this actually reduces about 0.154 every year. Now, going to the tweet prediction model, this is a sample of the prediction, and these are the steps. The models which I spoke about earlier where a Flask application was developed, web page was built, and it was deployed using PyEnvelope. All right, this screenshot from the model, I will just quickly do a demonstration now. Yeah, this is my notebook, and this is what the page looks like. All right, so I'm going to quickly check. I would like to use, I hope Mr. Wale doesn't mind. I'll go ahead.
Remy, your time is up.
Yeah, right.
So,
all right, this shows a tweet from, just a minute, please. A tweet from Mr. Wale, and we can see that this particular tweet predicts mental health concern. Please don't die. We're about to get that. All right. I'll just go to conclusion. My conclusion is that there's actually been a decline in suicide rate over time, and this has been a result of mental health awareness worldwide. And I think more work can actually be done in that regards. So this application can be useful in many ways for accessing an individual mental health, and brand and other individuals can use them for promotion. Yeah, thank you.
Yeah. Thanks for your presentation. My understanding is that this is sort of, so you're using tweets data to predict sort of sentiments around suicide, right? Is this tweets? Does this sound like, or does it look like something that is suicidal or not? And I mean, this data set is already labeled, right? But one thing that I did not really get is that, is there anything around the causes and the preventions, right? So, because I could see the titles like suicide causes and preventions, like are there other insights? Because most of the EDs and most of the data that you presented are mostly around the numbers of suicide rates per 1,000 people or thereabout, and how you could see the trend over time, right? So are there sort of, fine-grained nuances around like the data that I would say, oh, this is how to probably prevent it, maybe with active intervention or things like that.
Okay, so I need to clarify that there was actually a mix-up in the topic. The initial topic was suicide causes, but that was not the project. We corrected that earlier, so I'm sorry for the mix-up. The project is actually focused on accessing mental health via social media, which is Twitter in particular. So we didn't exactly do anything regarding the causes of mental health because we didn't have data on that.
Okay, and then my other question is that, what if you had more time? What do you think you would have done better or done to probably improve what you have right now?
Sorry, can you say that again? I didn't get the last part.
I wanted to say, if you had more time, what do you think you would have done to improve what you have right now?
Okay, yeah. If I had more time, I think I would have train the model more because I had just 89% accuracy. I think I can actually do better than 89%. And also, the web page, the HTML is a little bit poor, but I've deployed it in a more better way actually.
Okay. And then what features are you using for your data?
What feature? Sorry, can you say that again?
So you have because all you had was your text. So it could be maybe tweets or text or something, right? And then for each text, you're trying to like predict if the text, if it's suicidal or not. So I was wondering, what are you using as a vector representation for your text? Are you extracting? What features are you using? So maybe I'm not explaining well. How are you taking your text and converting it into some form of vector form that you then feed into your model? I don't think I could see. I can't see anything like that.
Yeah, this on the screen is the steps that I took. That's a data tokenization.
Yeah. So yeah, I understand. You take your text, you actually sort of tokenize it, and then you do some cleaning. Maybe the cleaning is for you to remove stop words and things like that. And then you stem and you lemmatize, which means you take words and you sort of shrink it into a much more global representation of each text. The last one, I think, is where I don't understand the feature extraction. How are you extracting your features?
Okay, I used TD vectorization for the extraction.
See what?
TD vectorization.
TD.
Pardon me, TFD. Yeah.
Oh, okay, I understand. Okay. So that's what I didn't see. So use the TF-IDF, the term frequency. Okay, inverse document frequency. Okay, that was what I wanted to know. And then you feed your TF-IDF vectors into your model. Okay. Yeah, sounds good. The other thing I would just say is that technically, because you have this text, and sometimes you have to remove stop words, and just think about it. If someone say that, let's say I'm texting and I say people who are suicidal need to go to the hospital or something, right? Generally, your model is gonna, I say people who are the who and the are probably not going to be part of the model, right? So your model is actually going to tag that tweet as suicidal, but that's actually not suicidal because that's more of like a recommendation to other people, right? So sometimes trying to use like classical machine learning methods, it fails to understand the semantic relationship between words in a text, right? So, and you get that. And so that's where sometimes, using sort of like advanced NLP techniques sort of normally helped. And I think, if you have more time, it's actually going to be really nice to see, instead of using a TF-IDF vector, for example, is this something that you can use some form of word embeddings where you're actually trying to embed sort of like each text and create like some embedding vectors for them and feeding them into like some neural network. So that definitely with that, you get a much better evaluation metrics. Your text accuracy will be better, but also that you're actually capturing some of the sort of semantic meanings of this text. So, but overall, yeah, good job. Thank you.
Thank you very much.
You're welcome. Yeah.
Yeah, thank you, Raimi. Great job too. Well done. So we move on to the next group, VSpy, and to lead in their presentation, Sayak Malik is already sharing his screen. All right, proceed, Sayak.
Good afternoon. I am
Yes.
Ebole representing
Right.
Team VSP. We worked on card fraud detection. Group presenters are Gospel Ebole, Sayak Male. These are the active group members. Next slide. The unauthorized usage of credit card or debit card or similar payment tools to fraudulently obtain money or property can be termed as credit card fraud. It can be an online or offline mode, and it comes in forms of card theft, account bankruptcy, device intrusion, and application fraud. Credit card fraud detection using machine learning is the process of using data to investigate and build models that will detect and also flag off any fraudulent activities. And it is a form of classification, which is either flags off a transaction, either legitimate or fraudulent. The world of technology today is moving into online payments and e-commerce, which deals with more of use of credit cards. And there have been a rapid increase in credit card fraud in the recent past that have led to loss of money due to credit card fraud. The data analysis allowed us to detect fraudulent transactions from not fraudulent ones and made inferences from the data. The goal of this project the goal of this project was to create an efficient machine learning model which can predict whether a card is fraudulent or not, and also to observe patterns in it and make inference. We got our data from Kaggle source, which contains data set of European card holders from 2013 till date. Our approach was data cleaning and profiling. Then we carried out exploratory data analysis, then feature engineering, machine learning model for inferences, and also deciding the best model. The data we used during data cleaning, data we used was noticed to be encrypted using principal component analysis for security reasons. We also noticed that there were no null values, and there was also a huge imbalance in the data. That is, the number of fraud values was 492. The number of non-fraudulent values was 284,315, which resulted in a huge balance of percentage of fraud transaction, which was 0.173, when percentage of non-fraudulent transaction was over 98%. Then we carried out exploratory data analysis. You can notice from the pie chart, the pink indicates non-fraudulent one, while the very tiny blue indicates the fraudulent activities, which shows the huge imbalance in the data sets. Then we carried out data visualization. We tried to check for any kind of correlation between the features, and then we noticed that none of the features exceeded either 0.5, either positively or negatively. Hence, none of them were redundant, which is why we continued without excluding any feature from the model. From here, I'll hand over to my colleague, Sayak Malik, who will take over from feature engineering.
Yeah, hello. So to achieve a balanced data set, we use the IMB learn technique using SMOTE to upsample the minority class. And we use the extra trees classifier on that data after that to find out the top 20 important features because working with everything would not be convenient. So we picked out the top 20. Once we were done with that, we found out that these were the top 20 features, but unfortunately they're encrypted due to security reasons. So we didn't really find a meaning behind it. But then we tried to fit models to our data set. Yeah. So we tried a decision tree, a random forest, XGBoost, and light GVM, all of which are cutting edge classifiers. And due to the presence of the imbalanced data set, this is very important that accuracy would not be the correct metric to actually measure the success of the model. I think it's better to use a area under ROC curve, which was used. So using these 4 models, we found out that the random forest classifier came out as the best performing model. You can see that area under ROC curve has been used, and we got almost 98.98% of area under the ROC curve. So summarizing, we can say that based on this data analysis, that linear models cannot be really used to predict the outcome successfully. Classifiers such as random forest, decision tree do a much better job on it. But if we had to recommend one model, we would probably go with the random forest classifier. Okay, so the conclusion is that credit card fraud can be predicted much better if we have good data and an unencrypted data set. And for now, we can just recommend that a random forest classifier does a fine job of it. The challenges that we faced was we couldn't really understand what the features are, and since we couldn't do that, we couldn't really deploy the model also. Also, there was some issue with the time constraints. We had some issues with that. Otherwise, yeah, this is the outcome of the model, and this is our recommendation for further analysis. Maybe some usage of statistics can be done as a statistical model using confidence interval could have been like implemented and compared with. For now, I think we would use a random forest classifier for this kind of prediction. Thank you so much.
Okay. Yeah, this is a little bit tricky, especially since this is mostly data for a competition, right? And a lot of the features they've been hashed that you don't you don't have like meanings to them. Okay. Yeah, so that's a little bit difficult to sort of like make recommendations on. But also my question would be the question that I asked some people a while ago is that when you're building a fraud detection model, what do you think? What would you optimize on? Do you want more false positive or more false negative? Which one would you go for?
So I think it's better to predict, even if there is a slighter chance that it might be a fraud, it's better to predict that it's a fraud and then it can be rechecked. Yeah. Instead of, since fraud is a risky topic, just like the medical scenario that we spoke about before,
yeah,
it's better to have, be safe than sorry. So that would be my safe one.
So what if you do that and then you started noticing that customers get pissed off and then they decided to leave?
Okay, so I think that also can be an optimization problem, because checking also might have incur some costs to the company. So maybe you also try to fit a model to it or something, or maybe you optimize how many times your model is actually predicting falsely, and then maybe we need a major change. Yeah, maybe we use a different model altogether for it.
Okay. And then the final question is that I think I saw that you guys had imbalanced data set at some point. What's the percentage?
So there were 99%. Yeah.
That's no, that's some yeah. That's that's a lot. And
that's
what
the
did
problem
what
with
did you guys use?
We used a random forest classifier.
Did you even area under the curve? Okay, so I don't know if area under the curve is probably the right metric to look at. I would guess maybe F1 score. The micro average F1 score because it looks at, but did you do anything to sort of try to balance the data? Did you maybe, did you maybe try like smooth or some oversampling technique?
Yeah. We used SMOT actually.
Okay.
So we use SMOT and then IMB learn to just upsample the data, because otherwise it's too much imbalance.
Do you know what some of the drawbacks of oversampling the data? Because you look at, you could see, 99.8% to 0.2% could be a problem, right? So mostly what happens when you oversample is that you can actually introduce more noise into your data set, and then when you have like an unseen test set, you can then have problems with it. But yeah, if I'm doing it also, I'll probably go with the smooth route and see. But yeah, apart from the fact that I don't think the choice of data set is great because you're unable to like physically interpret whatever's going on. Yeah. The approach to modeling, I think it's good. Yeah. All right.
Yeah.
Thank you.
Yeah. Thank you so much.
You're welcome.
Yeah, thank you so much, Sayak. Thank you, Godspar. Thank you, Wiley. Well, one of the interesting things about this group is that all of the members of the team Vispy has been showing them so much love on YouTube. Margaret Olulokwe, David Ndubisi, and here on Zoom, COC, Titila are showing you their support. So well done, team Vispy. Best wishes. So before the next presentation, which will be given to us by Sonali Arora, on the stock prices prediction. Let me welcome one of our esteemed judges, Charles Adetuluye, who has Charles is here. Okay, yeah. Charles, welcome aboard. We missed you a good deal.
Oh yeah, sorry about that. I have some technical difficulties out there. Sorry for the lateness.
It's fine. Thank you, Charles. Thank you for making it. So Sonali Arora.
Yes, sir. I'm ready. Should I share my screen?
Yes, please share your screen.
Okay, sir. So is my screen visible?
Yeah, we can see your screen. Please proceed.
Okay. Okay, so good afternoon and evening to the judges and everyone present here. I am Sonali Arora, a member of XG Boost Group, and today I'll be presenting analysis on S&P 500 dataset on some selected stock and discuss some of the graphs based on the same. So this is the main team, that is team lead, that will be Sonali Arora. And this is as the project was done in an analysis. So we divided our project into different stages on the basis of the topics like the data collection, processing, EDA, etc. And then we implemented the same on the data set to get the most out of it. Now coming to the main problem statement. The problem statement is to predict the rise and fall of the prices of S&P 500 dataset shares in the stock market by understanding their trends from the dataset. Basically, the objective is how each sector can impact the trend on the market, that is the stock prices. So about the dataset, that is, it features 500 leading US companies which are publicly traded with primary emphasis on the market capitalization. It is widely considered as the best gauge for large cap US equities, mainly funds. Many funds are designed to track the performance of the S&P 500. Now, the companies which we have chosen for this analysis are Amazon, Google, Oracle, and Microsoft, which are the famous ones. And this dataset is primarily a time series dataset, which tracks what is a time series dataset is basically it tracks a sample of data over different time periods and also checks which other factors influence the certain variables from different time. Now proceeding next, what was the process or the flow for the analysis, that is data collection, processing, EDA, feature engineering, model development, and yeah. So next, coming to data collection, that is we got the data set from the Kaggle website. Companies that we analyzed, I previously mentioned Google, Amazon, Oracle, Microsoft. Result, the main outcome for this analysis would be predicting closing values of the stock prices of the above mentioned companies. And the features that were present in this data set are date, opening price, highest price reached, lowest, close, volume, and name of the stock price. This is the feature engineering that we were able to get. And now coming to the main point, that is the model selection. The model that we have chosen for this data set is the LSTM model. Now, LSTM model, long-term short-term memory. It is a recurrent neural network capable of learning order dependence and sequence prediction problems. This is a behavior required in complex problems, mainly like time series forecasting, machine translation, speech recognition, etc. So why did we choose this model exactly? It was possible only after application of different validation metrics for models we could work on, that is different models that we could choose before this one, that is ARIMA, that is auto regression, moving average, and LSTM, that is long short-term memory, and that is profit, NNETR. So we chose this one after applying the validation metrics like MSE, that is mean square error, MAE, that is mean absolute error, and then we could come to the conclusion that we should choose this model because it provides the maximum accuracy. Yes, so next we come to the model training part, that we have used a min-max scaler to scale down the data to bring it to the feature range between 0 to 1 so as to get a normalized data. Now model training. Now the main part is how did we use LSTM model to give us the required output, we used the sequential, dense, and then the LSTM. Sequential layer was used to initialize the neural network. Dense was to add the densely connected neural layers, that is this one. And LSTM, that's the main model, to add the long short-term memory layer for the prediction, and dropout, that is used to remove the layers which prevents the model from overfitting. And we optimize the final model using the Adam optimizer, and found the loss incurred while analyzing the dataset by using mean squared error. So this was some of the graphs which can explain the model that we have used. This is for the Amazon stock. This is the Oracle. This being Microsoft, this being Google. And this came out the prediction of the model for the Microsoft stock, the Google stock, and Amazon and Oracle. Yeah, so coming to the challenges faced during the project that we are discussing. So basically the data set was not complete, and many stages required more standardization and cleaning of the values. And this could have been more efficient by cleaning the data set in a more efficient manner. That is, the data set provided was a bit unclean in the start because the values were not complete. The values were null in some of the data sets that we have, like some of the stocks that we considered. And if we would have gone more time, so we would have analyzed in a much better way, and also implemented the model ARIMA, that is auto regression moving average, because that provides a much more better implementation than the LSTM one. But compared to the model that we require, that is for the long-term effect for the prediction of the stock market data, so we preferred using LSTM rather than ARIMA. So that is the main conclusion of the project, that the project was due to some of the missing values of the stock data, the predictions may not be accurate. Yes, sir, this is the last part. So due to the missing values in some of the company stock data, the predictions may not be accurate as per the model that is LSTM used. So if we would have gone with the ARIMA model, that is auto regression moving average model, so we would have provided a much better accuracy for the predictions. Thank you.
Yeah, thanks for the presentation. I was actually wondering, did you have a way to validate your model? What are your metrics?
So the validation metrics that we used for like the models that we actually chose for this data set were a ARIMA model, that is auto regression moving average. Then we use the LSTM, which we have implemented through this project. Another was exponential smoothing, and NNETR, that is neural network for time series forecasting. So the validation metrics we could implement were, that is the mean square errors and the mean absolute errors, and the best possible, like the minimum ones we could get was from LSTM. So that is why we implemented the LSTM model, which provided the best metrics for the prediction. I hope that answers the question.
Yeah, I was just wondering why you guys don't have it on the slide deck, because I think sometimes it's always good to have it so that you can benchmark the different methods that you used against each other. And also another thing that I note, so this data is from what year to what year?
So this data set, just give me a minute. It's actually, sir, 5 years data set. So
okay.
Not from the recent ones. It is generally from 1980, maybe from 2000 to 2000. It's from 2017 data set. So you can say from 2011 to 2017 stock pricing data set.
Okay. Yeah. Also, so the reason why I'm asking is that, I mean, in terms of the close price, it kind of looks straightforward, because you could see that there's some form of like linear relationship going on. That's one. Then two, you don't have a lot of like seasonality in the data, and so maybe there's some level of stationarity in it. That's true. And I was just wondering how this model is going to do when you get to like year 2000 and 2020, when there's COVID. I mean, it's going to perform badly, right?
No, sir. We can even add more like metrics to improve the model prediction. Like rather than just we can make it more efficient by providing.
No. What I'm saying is it's not like a. I'm not saying like the model is not good, but I'm just saying that stock price prediction sometimes could be very tricky because there are things that you would never account for, like COVID, right? That you don't know that COVID is gonna happen a few years ago, right?
Yes, sir.
Yeah.
Yes, sir.
So when it gets to that period, okay. Yeah. So yeah, I think overall, great job. I think I would expect to have like the different metrics, and that would allow you guys to be able to benchmark the models against each other. But overall, yeah, thank you.
Okay. Thank you, sir. Thank you so much.
Welcome.
Yeah, thank you, Sonali. Thank you, Wale. So we'll move on to the last presentation for the internship, and that will be given to us by the Optuna Group. Iwiakin Bumin. It's talking about object orientation. Oluwabumi Iwakin. Sorry for mispronouncing your name earlier.
Yeah, no problem. Good evening, everyone. Oh, still in the afternoon. So I'll be sharing my screen now. Okay. All right. I believe you can see my screen, right?
Yes, we can see your screen.
All right.
Yeah.
Okay. So first of all, let me just apologize on behalf of the team for missing our last presentation. And because of that, I'll just be making this very, very brief. So basically, we know that the eyesight is like one of the most essential like human senses that we have. And it is what helps us to be able to go about with our daily activities. And we know that for those who are visually impaired, this just makes things a little bit difficult for them. And we have different types of visual impairment, uncorrected refractive errors, so age-related macular degeneration, glaucoma, and the likes of it. Quick statistics, we know that the World Health Organization estimated that in 2002, about 2.6% of the world population was visually impaired. And 2020, this was recorded to be about 4% of the entire world population. And just as we mentioned earlier, these ones, they find it kind of difficult to get things, or they need help from people to be able to carry out basic things or activities that they need to go about on. And that is why our team decided to come up with something that could be of assistance to such ones. And it would be an app which is built on the breakthrough of image processing and machine learning. Basically, the whole process of what the app does is to capture real-time images, pre-process them, extract features, and once it's able to identify what's in the image, it can be able to use text-to-speech conversion to tell the person what is in front of him. So we collected the data set from Kaggle, and because we didn't get images that are annotated, we had to use a label image to be able to annotate the image or the images we collected. The data set which we used had 10 classes, 10 different classes, and we had to label each classes separately using the label image in the YOLO format. However, it was sad that when we used our model, we had a low performance. It was kind of frustrating annotating the images because there were a lot of images. we had to annotate about 300 images, although there were some more images, but annotating it was kind of strenuous. So we had to restrict it to 300 images. And for that, our model was poor, wasn't identifying as much as we'd want it to. And second, we thought, why would we just want to train on 10 classes when there are a lot of things a person might actually need in the house? So we decided to use the established FASTA or CNN mobile net, which has about 91 classes, different classes or objects or things that you could recognize. And we used it because we believed it is lighter in comparison with other pre-trained model, lighter in size and faster. So we decided to focus on product development. This is just a code snippet of us using mobile nets for our prediction. So on creating the app, this is what the interface looks like. We have the home page here, which is on the left, and you have the main operation page on the right. So the app was designed with the user in mind. You can see a big button at the middle of the screen. All you just need to do when you open it is quite difficult to miss. Once you press the middle of the screen, you don't even have to look at it to be able to get the middle of the screen. And the exit buttons and the other functionality buttons are placed just below, such that you can easily just trace it using the bottom of your phone. You know where your phone ends, and you can use your hand to stylishly navigate. The same way for the main operation page. Forgive my uncladness here. So moving quickly, I'll just give you a presentation of what the app does. All right, that is it. So we can see it is able to identify basic objects in the home using that demonstration. Although in all honesty, it didn't really identify every object. Maybe the accuracy wasn't so great. I'm sure using other models would provide greater accuracy, but because we want to stick to the size of the model such that it will be something someone can download on the phone easily, we decided to stick with MobileNet. The next step for this app would be to quantize the model, and I attached a link for anyone who might be interested in what quantization is to read more on it. Basically, it's like an approximation technique, converts the default 32 float type operation of PyTorch into 8-bit operation. And next thing we could do is to replicate this application. So I can call this application like a prototype kind of application. Replicate it on Android Studio such that we'll be able to use the Java interface to load in the quantized PyTorch model. And another option would be to use PyGenius, which allows for the use of the importing of Java modules in Python to be able to integrate Python with the Kiwi interface, which was used to build the app originally. Use it with Collab and Bulldozer to create an APK file, which is the default extension file type for Android phones. And we could deploy it to cloud services or the Google Play Store. Thank you very much for your time, and I think I'm done.
Yeah, thanks, Oluwabunmi. Yeah, I actually really do like the project. The few things I think this would be more of like comments and there'll be questions along the line. The few things that I could see that you did, which is the first thing, was to pivot when you notice that you don't have a lot of data and you had to like label about 300 data set or thereabout. So instead of you, I'm guessing you did not train any model. What you just used is you took like the pre-trained, maybe the pre-trained YOLO model or the pre-trained RCNN, and then you just applied it to the data sets that you have on the labels, right?
So I said we did use a model. We tried to build on the mobile net, and we said the performance was poor. So it wasn't recognizing enough. And more to that, we thought about it. We thought maybe we've been going about it the mediocre way, and we said instead of working with 10 classes, why can't we work with more? And that is what made us eventually decide to go back to just using the normal pre-trained model.
Okay, so just to work on, okay, so then you were using the pre-trained model. Okay, yeah, that makes sense. And I think also one thing that I also noticed that is that you're building the model and you're thinking more about sort of the engineering, so which is sort of the infrastructure and the implementation, because you kind of keen on trying to modularize this model, like, you know, package it into some form of Android app or something, and then you then notice that one, you cannot use the faster RCNN or the YOLO because they are much more larger in size, and then your idea is that what if you use a pre-trained mobile net, and then in the future you can actually quantize this model so that it's actually going to fit into your device, right? So you can have some form of on-device prediction, right?
Yes, exactly.
Have you looked at JAX?
No.
Okay, so one thing you can try to, so TensorFlow has like JAX, which is like,
okay. Sorry, I'm using I worked with PyTorch.
Okay.
So I'm not so conversant. I use PyTorch, but I prefer the way I use TensorFlow, but I prefer the way operations in PyTorch are more.
Okay. So overall, like I said, I really like the project. A few things that I think are missing is that even though you're trying to, like, you have like some test cases, I think it would have been better to present like some of the metrics, especially around the IOU and the mean average precision. So that kind of gives you a lot. I mean, also you want to be sure that you can deploy them. So you could have things around inference time, which means for every time that you serve the model, how long does it take to make predictions? And also things around mean average precision will tell you how well your model is doing in terms of like the bounding box prediction, because it's an object detection model, and also the different classes. So that would help. Another thing I could see that
okay.
Go on.
Yeah, I was going to say we did consider the speed. I took the speed into consideration because I felt at first is an object detection model where you have to get coordinates of the object in the image. We were drawing the coordinates and the bounding box around the images at first, and that was a poor choice because first of all, the user is not going to see the bounding box.
Exactly.
And second thing is that it meant that we have to take in every frame, make prediction on every frame. Yep. But after thinking for a while, I thought that why not just once you click the show me, it takes just that frame and ignores every other frame and makes prediction on just that frame. So
But what happens when you have multiple images in the same frame? So what happens if you have like a chair, a bed, a desk in just one frame?
So if you look at the video, the presentation I showed, it was able to recognize a person, which was me, and the object I was holding, which was a cup. So although I used a threshold for the accuracy so that it will be able to determine, which is about 80%. So the model has to be 80% sure it is what it is, or it is what it is claiming to be. So if it is a cup, if it is not 80% sure that it's a cup, then you just do not worry about it. Just let it go. So it's only when it's 80% sure that it sends that text to be converted to speech and let the user know what is before him.
Okay. At some point, I'll probably maybe reach out to you later on. But one idea that I had that you can kind of pivot is that I've been thinking, I don't know if there's a solution for this, but especially in developing countries like Nigeria, right? I don't know how easy for blind people to navigate using currencies. So which means that if someone gives them money, or if they want to pay, for example, and let's say they have a bunch of like 1,000 naira, 200 naira, 300 naira, is this, can you scale this to a situation where you just train the model just based on currency? So if you have 100, 200, and 100, you to tell them that, oh, the total money that you're about to pay or that you're receiving is 1,300, for example, or 250 or something, right? And I think this is like, in terms of like local context, this might actually be like a really, really good impactful project. And this is also something that you can test with, like, you can have real validation if you have like an app for it, like take it to like maybe the School of the Blind or something, and they can actually use this model real time and help and give feedback. But overall, yeah, great job.
All right, thank you, sir.
All right. Yeah, sorry that took long, Emmanuel.
That's fine. Let me start from your last word. Overall, great job. And this is to everyone that has made this presentation today, and not just today as well, not just today, but also last Saturday. We've had incredible presentations. We've had wonderful insights into the different topics that our interns have presented. And trust me, this is one of many, 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 many wonderful presentations to come in the future. So before I give my remarks and votes, I'm sure Wale and Charles would have a lot of things to tell you, our interns and our presenters, and those are intending to come on board with respect to data science and data science presentations in the future. So maybe I start with Wale, right?
Hello.
Yeah, I can go fast. I think the quality of all the presentations were really, really, really good. I think there were a lot of thoughts that went into it. I really liked them. And also a lot of the comments that I made were like, some of them are things like, if you have more time, right, these are some of the things you should consider. So, and I had a few comments written down, probably maybe Emmanuel and Cole can share with you guys individually. There are a lot of things around, a lot of like good analysis and experimentation, but sometimes you also need to think about the project in terms of, what if I am the business manager or the board of director, right? How can I, or let's say I'm a stakeholder, maybe I'm the doctor or something. How do I make sure that my models or my work is sort of more explainable? And also, how do I think about the trade-off between, do I focus more on like trying to like reduce false positive or reduce false negatives, right? So sort of this post hoc analysis after your model, I think it's extremely important. It also shows that the business values of your project beyond just the metrics. So I'd say just think more about it, about how your project would be used in real life. And I think if you get to that stage where you can articulate that better, I think that becomes even much more better. But overall, I would say good job, guys. If you have time, you can write this up as a Medium article. You can have your code as part of your portfolio. And these are some of the things that companies want to see, hiring managers want to see. So great job, guys.
Hello.
Yeah, thank you. So these are some of the things that hiring managers and companies want to see. Thank you,
Hello?
Wale. Okay, so Charles, you were present last weekend and you saw some of the presentations and you judged them as well. And
Hello?
I think you saw a few of the presentations here today. So, so any recommendations you may want to give as well?
Sure. Yeah, and sorry a little bit for the time. Sorry for the tardiness on my side this morning. So I think the presentations from last week that we saw were very great. I caught the last part of this presentation, but I didn't want to introduce any bias, so I let Wale just do his thing. So, but judging from the last few presentations I saw, the quality is great considering that you guys didn't spend a lot of time and it's all like a big time project and we're able to pull this out. That's a testament to what you can do if you have more time. And this was a big project for a big organization that's sponsoring. So I think overall the quality of work is impressive, but the goal is not to rest on your laurels based on what you've done right now. There's a chance to improve all the things that you've done. Like Wally said, extend what you've done, make it better, build it up. Try to collaborate with other people on it to make it better, make some presentations and write-ups and blogs on it so that people can see what you've done and things like that. But in terms of the quality of work, I'm impressed by what I'm seeing, especially the last presentation was very, very good. There's a lot of application to that and computer vision, object detection. It's a very big thing in the industry right now with self-driving cars, IoT devices, and things like that. So I'm really impressed by that, what you did, your attempt at solving the problem, but there's still a big being able to do more. So, and you guys should not just take this as a final and just go relax. If you have any questions, just reach out, tap into the network, continue to improve yourself. And I think the sky is not the limit. You guys are up to a great thing. Thank you all.
Thank you, Charles. Thank you so much. The goal is not to rest, and I think that's those are words of wisdom from the great Charles Adetilo himself. So thank you very much. I think I'll have just one more question for you, Wally and Charles. From your last statement, Charles, you said the goal is not to rest. So considering that these people now are officially, ending the Hamoye data science internship with this presentation, and then maybe on Tuesday they will be getting their final certification. What would you say should be their next realistic steps for them to climb up the ladder in the industry?
Yeah, that's a very good question because at the end of the day, this is what you guys liked and you're interested and you love doing. That's why you dedicated this so much time to it. So I'll say don't just disconnect and sit there and okay, you've done this, what next? Try to plug into a lot of open source projects. And I think Hamoye is trying to do a lot of things like that, where you just contribute back what you've done and you become a part of a larger thing. Someone was using PyTorch out there. There are a lot of models that people contribute. There are a lot of different implementations. So don't just end things right here. Try to find a great open source project where you can participate, even if it's just documenting things for them. Just keep yourself active in that community, and somehow, some ways, I trust. I believe someone will find you out, even if you don't have a job right away. That keeps you busy and that keeps you occupied. And tap into the network. Keep in touch with everybody around you. Especially in this community that we're building together and we're growing. Somebody will reach out to you and stuff like that. And connect with us on LinkedIn. If there's any questions, if there's anything, if we see any potential opportunity that we can match you with, you guys will be the #1 preference before we consider anybody else. So I think that's the way to go in terms of keeping yourself out there so that you can get a job, get something fulfilling, and building on what you've learned from it.
Yeah, thank you so much, Charles. Tap into the network, guys. Tap into the network. Words of wisdom again from Charles Adetilo. Thank you so much, Charles. Wale, do you have any additions?
Yeah, I think I'll just mostly echo what Charles said. So just network, add us to LinkedIn. If you, for example, I currently work at AWS. If you find a job or something that you qualify for, and you want to refer, just send me a message. I'll definitely refer you. And then just keep working. Also try as much as possible to make sure that your learning is more project based than trying to learn all the concepts. Like when it's time to learn the concept, you can do that, for interviews quickly. But sometimes you learn more when you view the project, and try to also work on projects where you don't even have data from KU, that you could think about the data, go do some web scraping or get the data yourself and do end to end, from getting the data, labeling it, down to deploying it. So having, improving your project portfolio, I think that's also pretty important. So yeah, I think you guys are on the right path, and yeah, I'm rooting for all of you.
All right, make sure your learning is project-based, increase your project portfolio, and I think we're on the right track. Thank you so much for those words of wisdom there, Wale. Thank you to every presenter, every group member, every intern, and everybody that have graced the presentation last weekend and today. It's been fruitful, it's been exciting, it's been insightful, and in a very special way from all of us at Hamoye, we want to say thank you for all of your input and contribution. In a very special way, we want to thank you, Wale Akinfadari, sorry. You've been immensely impactful on these people and on us as well. The program itself and, the results and the outcome that we've seen. Thank you so much for everything that you've done for our interns and for us, Wale. And Charles as well, thank you for always bringing, the best out of our interns, the best out of the Hamoye trainees. And in a very special, I want to thank you guys. Thank you so much. And as well, Biodu Awujobi in absentia. He was here last weekend as well, but unfortunately he could not make today. So thank you again. Thank you to every member of the Hamoye team. I know this may be coming late as well, but it's 2 days late, but happy Thanksgiving to everybody as well. So thank you all. Thank you for making our time. Thank you here. And for our interns, the official close of the internship is the 30th of November, 2021. And that's when you get your certificate of completion, if you qualify for the certificate. Remember all of the criteria for being certified in internship. And as well, you can also extend the news that the call for application for the 2022 Hamoye Data Science internship is on. So the links have been posted on our YouTube page, or on our YouTube chat and on the Zoom chat. So you can share them with friends, you can share them with people you know who are interested. And as one way as well, we would always keep in touch with you, just like Charles mentioned, just like Wiley mentioned, we'll also always keep in touch with you. So feel free to connect with us, feel free to connect with Charles, with Wiley, and all of our mentors, as you go forward. Again, congratulations on reaching this stage, and thank you for being a part of the internship. Thank you so much from all of us at Hamoye. Best wishes and bye for now.